Hello everybody, so this is again Dr. Sergey Sargasov, and we're going to graph circles today. So let's call this topic basically the algebra, right? We're doing algebra, and so we're graphing circles. That's what I want to look into. And we'll do one or two examples that will make sense of the topic, hopefully, for the most part. So first of all, let me write a relation. Remember, like x and y and an equal sign between them, right? And x and y related. We've discussed already functions and relations to a degree, right? Let's specifically imagine you're graphing something like this. X squared, right, plus a y squared is equal to 25. Just imagine you're given this relation. Now what I mean by relation is if x is something, for instance, let's say x is 5. What's 5 squared?
-3.
What's 5 squared?
25.
25, right? Okay, so let me look at this. If you do 25, put x equals 5 in, right? And you do 5 squared, you get 25. 25 plus what is 25?
25.
So 25 plus what is 25?
Oh, 0.
0, right? So if x is 5, right? Yeah. Then y has to be 0, right? And so the relation is that 5 is related to 0. 5 is not related to 1 or 2 or 3. You have to have, if x is 5, so let's draw a little picture here. If x is 5, then y will be, y has to be 0. There's no other option. You can actually solve it, but 5 in, 25 plus 0 squared is 25, 0 squared. I mean, y squared is 0, and you get y equals 0, right? Now let's try another number. How about a -5 for x? What's -5 squared?
Oh, it's still 25.
Still 25, and if I add what to it do I get 25?
0.
So again, y squared is 0, so y has to be?
0.
0, right? Okay, so these are related. It's almost like me telling you, hey, you know what, everyone? Here's a relation, and you're going to sit this way, where this is columns and rows, and you go to this movie theater or whatever, and you have to sit in specifically, for example, column 5, row 0, or column -5, row 0. But you cannot go to column 5, row 3, because that's not going to be 5 squared plus 3 squared is not 25. Okay, let me show you some other examples. So for example, let's try 3. Let's try 3, right? All right, we'll try 3. What's 3 squared? 9, right? Okay. So 3 squared, let's put this x equals 3 in, and we get 9 plus a y squared is equal to what? 25? Okay, so what is y squared equal to? Subtract 9 from both sides. What's 25 minus a 9?
I think it's 16.
16 it is, right? And then if y squared is 16, how do you find, by the square root property or whatever, how do you find what's y? What number, there are actually two numbers. What numbers squared give you 16? Remember, we always say plus or minus.
I think it's 4.
4, and exactly 4 it is, right? Because if you do 4 times 4, right, you get 16, right? So what happens is, if you do 3 squared plus 4 squared, you're going to get 25. 3 is related to 4. What if you do 3 and a -4? You'll also get 9 plus a 16, 25. Okay, so these are the related relationships. And also you could do -3. You would also get 9 plus, and then you can do 4 and -4, right? Everyone? Yeah? And then what if you do like a -4 or a +4? You can do plus or minus 3, right? So we can do plus or minus 3, plus or minus 4, plus or minus 4, plus or minus 3, 5, 0, 0, 5, right? We can do 0, 5. What if x is 0?
The y has to be negative
or
plus
positive
-5.
5, exactly. So you get, like I said, plus or minus 5. Now let's graph some of these points. Remember what graphing is about. Rene Descartes in the 1700s, what do? He said, you know what, if we have an input x and we have an output y, this is more like talking about functions, but even this relation x and y, we'll say, you know what, the x is horizontally moving on the real number line horizontally. Y is the vertical motion, and remember what rectangular coordinate system is. Let's do this in another color here. What is a rectangular coordinate system? It's when we have the x-axis, right, and the y-axis. We have these axes, two axes, they're perpendicular to one another. Anyone remember that? So we have this, I'll call this the y-axis, right? And this is the x-axis, horizontal. And so what is graphing? Basically, you have the x value, the y value moving vertically, and this is an ordered pair. You take an x, y, you make it an ordered pair, it's also called a coordinate, and you graph it as follows. For example, what is 5, 0? 5 is horizontal for the x, right? So you move where? Left, right?
Right.
Right what?
5.
1, 2, 3, 4, 5 units, exactly. And up, down what?
Oh, you just stay there.
Stay there because it's 0, right? So you stay right here. So the vertical is going to be 0. So these are rectangular motions. For instance, 3, 4. Where's 3, 4? Right what? 1, 2, 3. And what about
Up 4.
up 4? 1, 2, 3, 4, this number line. And you see a number line by number line, it's a two-dimensional object giving you a plane. If you ever wanted to go to 3 dimensions, what would you do? You would actually have another number line, like a z-axis as we call it. And then, like, I think about this stacking plane on plane on plane, like sheets of paper forever onto each other, because they're infinitely thin, but if you put infinitely amount on them, you get a cube, you get some kind of a three-dimensional object. Anyway, there's a point, 1, 2, 3, 1, 2, 3, 4, yeah. What about this point? 1, 2, 3, 4, and is there a point 4, 3? Yeah, there's a point 4, 3. What about point 0, 5? Is there a 0, negative 5? 1, 2, 3, 4, 5, okay. What about like a negative 1, 2, 3, 4, 5, 0? Remember talking about that. What about a negative 4 up 3?
Yeah, you could do that.
Or negative 3 up 4. And anybody see a shape that's developing as we're sitting in these locations? We're sitting in a, it's not a square, it's not a box.
Pac-Man?
What is that?
Is it oval?
It's even more oval. So what kind of symmetrical? We'll call it a circle.
Sphere?
Right?
Oh, circle, yeah.
It's going to be a circle. Cool, right? So negative 4 down 3. Negative 3 down 4, right? Like those are points. And actually, if you did 1, you would have 1 plus what squared gives you, plus what gives you 25. You'd have 1 plus 24 gives you 25. You solve it, you get square root of 24, 2 root 6. But the idea is it's close to, it's 4.9-ish. So if you go here, you would have a point right there. You could find it. It's just a little messier of a number, right? We don't like square roots of numbers that are not easy. But what happens is we get this circle. That's the graph of this relation. And now the question is, you know, it looks like a circle, right? But what in the world is a circle, and why do we think it's exactly a circle? Because, hint, hint, this is exactly a circle of radius. How long is this thing right here from there to there?
5 units.
5. And this one, what do you think this is going to be?
Probably 5.
5. But think about it. 3 squared, 4 squared plus 3 squared is 25. Remember that distance formula? That's what we're going to talk about right now. So the distance formula, really quickly, the distance between 2 points, let's call them x1 and y1, x1, y1, and, x2, y2. What's the distance? Remember, we talked about this. It's a Pythagorean theorem application by Pythagorean theorem. What is Pythagorean theorem? Remember? Anyone? It's when you have that, remember a squared plus b squared equals what? The c squared?
C squared?
And what is that? So Pythagorean theorem, basically, if you have a right triangle, right? And you have the a, b, and c, that's what we have, the a squared plus b squared equals c squared. The sum of the legs, the squares of the legs, is going to equal to the hypotenuse squared, right? It's a topic in geometry. I actually teach it in trigonometry, the proof of it. We don't see the proof here yet, but Pythagorean theorem is this. So look, the horizontal distance, let's say we have a point x1, y1, and a point x2, y2, right? What is the horizontal? It's the change in the x's, right? This is going to be delta x. What is this? The change in the y's. What do we call that?
Change in y.
Change in y, delta y, right? And so this is distance. Distance squared, just like we said, c squared is equal to what? A squared, which is delta x squared, right? Plus a delta y squared for the b squared, right? What is delta x? What do we do in terms of x1 and x2? Delta's difference is change. What's difference? Adding or subtracting?
You would subtract.
Subtracting. So you say x2 minus x1 squared plus a y2 minus a y1 squared, correct?
Correct.
And that's the distance squared. What is distance? The distance formula says, oh, you know what? Square root of plus 1. By the way, distance is a positive number. Like I would, if I said distance is 5 or negative 5, I want 5. I'm talking how far away are we from each other. It's 10 feet. We don't say negative 10 feet. That's weird.
I don't think it's 10 feet. It's
Whatever it is, though, right? Yeah.
Right.
So we're going to say the positive number. So plus the positive square root of x2 minus x1 squared plus a y2 minus y1 squared. That's the distance formula. We proved it. Now, here's the idea of what a circle is. What is a circle? Definition. It's all points from a center at equal distance away from it, right? So circle is a point, all points. This is what a circle. We know this without even knowing anything else. We know that a circle is, by definition, all points equidistant, at equal distances, equidistant, okay, from a point, another point, and what is that point called? The center of the circle, right? Yeah, but it's called the center. The origin is, here's the origin of the center, but if the circle's centered somewhere else, it doesn't have to be the origin, right? So anyway, from the center, right, which is another point. Center, and what is equidistant? What is the distance? Let's write it here. Circle is all points equidistant. That's the radius. Right? That's the distance. The radius is a constant distance, and equal distance is equal radius from the center. So all points equidistant from.
Equidistant is a word?
Yeah,
Oh.
from the center. Okay? And
I've
so
never heard that.
center and radius. If we know the center, think about it, and the radius, we know the circle. If I know, hey, you know what, the circle's here, that's this big, the size of it, that's it, we're done. So what's the radius here? We're thinking, it looks like 5. What if we said, we look at this equation, x squared plus y squared is 25. Let's write it a little bit differently. Let's look at it this way. Remember, x squared plus y squared is 25. What about x minus 0 squared plus a y minus 0 squared? What is that equal to?
X squared.
So it's still x squared plus y squared. What is that? What we said is 25, right? Which is 5 squared. What is this? Let's square root it.
Which is x squared.
Let's square root it. That's 5, right? Square root of 25 is 5. What's this? That's the distance between distance. Let's put a distance formula. Put a D for now. Between any point, xy, right? And what point? Remember x1, y1, xy? What is this? What do I put there? Instead of x2, y2, we could put it to be 0, 0, 0, right?
0, 0.
And so this is the origin. This is the center. This is for points in a circle. Get it, everyone? Why is that? And the distance is constant. It's always, radius is 5. Cool, right? So we always have 5 is equal to this distance between the point, anything on the circle, turns out, and the radius and the center, the origin here. You see, so we have proven that, yeah, indeed, this is a circle. Radius 5, square root of 25, that's why we have 5, and this is origin, the center is 0, 0. So now, let's look at another example. Okay? Like a quicker example. That's something a little bit more, like now that we know this, a little messier looking, but how do we graph another type of circle? So for example, we did this one, right? X squared plus y squared is 25. What if we go on, and remember, this is how we've proven that this is basically an equation of a circle, again, radius 5, centered at 0, 0. What if now, ready? We'll take another, this is a different color, let's not erase too much here, we'll erase this. And we're going to graph the following. What if you're told, you know what? Graph, okay, the relation, and a little different, just a little different. How about this? X squared plus 4x, okay, plus a y squared minus a 6y, okay, and let's say that's equal to a, let's make it an easy number. How about this? That's equal to 3, okay? Let's make it equal to 3. Okay, what do we do? How do we graph this? This is a much uglier looking one, right? This is not x squared plus y squared is 3. X squared plus 4x plus y squared minus 6y plus equals 3. What in the world do we do with that? Remember I taught you, everyone, completing the square. It's a technique that's really tricky for a lot of us. But what happens with x squared plus 4x? It's x plus, what's half of 4? 2. 2. It's x plus 2 squared. If you square this out, it will be x squared plus a 4x, 2x plus 2x, the FOIL method, and plus a 4 on that, right?
Yeah.
So take away the 4. There's no 4 here. There's no 4, so take it away. Well, how do we complete the square on this? And a lot of us struggle with this topic, I get it. But look, what's y minus, what's half of the 6?
3.
3 squared, because you're going to have y squared minus 3 minus 3y. It will give you minus 6y. What's this then? Plus a what, 9?
This is positive 9?
Yeah, it's positive 9. Is there a 9 here, positive 9?
No.
Take it away.
Oh, okay.
So that's that. Let's double underline what's matching up. Okay, double underline, single, single. And this is equal to 3. Let's do what? Let's get rid of the numbers.
Oh.
Get rid of them. So x plus 2 squared plus a y minus a 3 squared is equal to, what's a 4 plus a 9 plus a 3?
Is that 16?
16.
Oh.
Okay? And look at this. We're about to get an amazing equation again of a circle, because what is this? This is actually x minus, remember how we did the distance formula? We have to have x minus something and y minus something, and this is going to be the center, right? So x minus, what's x minus what is a x plus a 2? Negative 2, right? Yeah, exactly. And so we're going to do this plus a what? Just y minus 3 is directly what it is, right? Put it like in parentheses if you like, squared, equals to what? What number is this squared?
4.
4 squared. So the center is what? Remember, it's a distance kind of squared between points x, y, and the points, what?
Negative 2.
Negative 2, comma 3, right?
Yeah.
Exactly. That's the center and radius?
4.
Exactly. 4. r is 4, right? Okay, so how do we graph that? Is that possible to graph now that we know the radius in the center?
Yeah, you just plot it at negative 2, 3, and then go up 4.
Yeah, so where's
Go
negative 2,
up
3?
4,
Where's
go right
negative 2,
4.
3? How do we graph that
Go
coordinate?
go left 2.
Left 2? Up what?
Up 3 units.
1, 2, 3 right there?
Mhm.
So that should be our center, right? Okay. And what about the radius? 4, right? So we can go, for example, 1, 2, 3, 4 down.
Yeah.
1, 2, 3, 4 up. 1, 2, 3, 4 to the right. 1, 2, 2, 3, 4 to the left, right? And so this is going to be our circle. This is just an approximation. Of course, nothing's perfect, right? We're not a graphing calculator. But we actually have more insight than a graphing calculator at this point. Okay? So it's better if you just graph with a calculator, like what's going on. We know exactly what's going on. It's all points at equal distance, which is 4, away from the center point. Center, which is what? Negative 2, 3. And the radius is, we're going to draw it like this. It's 4. Cool, right, everyone? And so that
is pretty cool.
And by the way, if we put the point 0 for, let's say 0 for the y, we could find what x values it would intersect. That's solving quadratic equation, actually.
Yeah, we could.
If you did, look at this. For 0 for y, this goes away. You get x squared plus 4x equals 3. And it's a messy number. It's nothing too easy. You get some square roots. But you do the quadratic formula, you get some numbers. There's some kind of negative something here, right?
Okay.
And so that's going to be a circle. And you can find basically any point on it. You can find it if you want. It just takes a little bit more computation. Sometimes quadratic formula is needed. And so this is going to be something like something with a circle, a kind of an approximate image of the circle. Okay, there it is. So the green one is kind of obviously smaller than the purple. Why smaller? This is radius 5. This is radius 4. Okay, that's it. So there's graphing a circle. And I just want to show you a little bit of that so that we can feel really comfortable with doing that. Let me give you one more problem. We're not going to do this. I'm going to kind of give you a solution. I'm going to do a little bit more in my head. Give me some points. Actually, let's do this. Give me like any point, like any random. So, for example, the next example, we did example 1. We did example 2 here, right? And let's do one more example. Let's do points.
Negative 73.
Let's do something easier. How about negative 7, comma 3?
Negative 4. Negative 4.
Negative 4, comma what? Some easier numbers.
It's
7?
3.
3, okay, and then negative 7, comma, or like make an even number.
Negative 1.
Let's make an even number.
1 and a negative 4. Or negative 1, negative 2.
How about, let's do positive here, right? Let's do, how about this? A 2, comma, negative 1.
2, 3, 2, 3.
2, negative 1, how about that, right?
All right,
Okay, sure. Let's make it a little tougher, because the 3 there will be a little easier. Okay, so points, and we have diameter, make diameter. So the line, connecting points, connecting these points makes diameter of circle, for example. Let's find the equation of the circle, and that's it, and we're done. So in other words, what's the circle equation or relation, right? Let's say we have this problem. So here we are. You have these 2 points. They're making kind of that diameter of the circle. What's the relation? So help me out here. Where's negative 4, 3?
Go left 4 units and then go up 3 units.
Up 3, okay. So that was actually, we had a point there already. Remember that? Remember that, everyone? Remember that? And so we had a point here already.
Who's that?
Let's see. We had a point here, right, everyone? And what about the negative 2, negative 1? Where's that?
Go right 2, down 1.
Down 1, right? Okay. And so, look, let's connect these points. That's what I'm kind of going for. We're going to connect them somehow. Okay? And we're going to have a circle between them. Okay? So I'm saying, here are the points. We're going to make a circle somehow. All right? Trying to make the marker, mess up the marker. But this circle right here, where this is diameter, let's pretend like we drew this, and we're like, what's the equation of it? Let's say we want the algebraic from the picture. Okay? So I'd make it a little neater looking. Trying not to intersect the markers, of course, not to mess it up.
Oh, you know what you're going to do?
But anyway, so look, let's finish this up for a little bit. So what happens is, does it look kind of like that, something like that, circle-ish? Okay, so what's the equation? Where's the center? Here's a hint for you. Where is it? It's called the what between the 2 points?
The midpoint.
The midpoint, exactly. What is that midpoint?
Midtown.
Exactly. What is the midpoint? What is the midpoint? So midpoint, you know, if I find the formula, you average the x's, average the
What's
y's.
the formula again?
You average the x's, average the y's. What does averaging mean?
Divided.
Add them, divide by 2.
Oh.
Right? So midpoint would be x1 plus x2 over 2. And what do you think the other one is?
Y
1 plus y2 over 2. Yeah, that's averaging the x and y values. Look, and we're going to have between. So look, this is a point, what was it again? Negative 4, 3?
Negative 4, 3.
And this one is
Negative 2, 1.
2, negative 1. So what is the averaging of these points? Negative 4 plus a 2 is a negative 2. Divide by 2?
Negative 1.
Negative 1. I'm doing this kind of verbally, everyone. Kind of just do this quickly now. What is 3 plus a negative 1?
2.
Divide by 2?
A 1.
So that's what we get. Negative 2 over 2 and a 2 over 2.
Oh.
There's a midpoint. Guess what that is? That's the center. Okay? Center. Guess what we can start right away with doing? We can say, you know what? We have x minus, what's the value there?
So it's a minus
So,
negative 1?
yeah,
so
which is?
You would add it?
Yeah.
Okay.
Plus
So
a 1, exactly. Squared plus
And then you do y minus 1.
Exactly.
But it's you just keep it the minus.
squared equals to, we don't know the radius, do we? We can find it. So find the distance between the points. We've done that already. The distance between the points by the formula is the square root of, what's the change in the x's? What's between, how far away is 2 and negative 4?
I think it's 6.
6, right? 2 minus a negative 4 is actually 6. So
Well, you have
6
to
squared,
square it, right?
yeah,
Okay.
plus, remember we're squaring,
This,
right there. And so what about how far away are these from each other? 3 up and 1 down?
4?
4, right? Because the 3 minus negative 1. 3 plus 1 is 4. 4 squared is equal to what? 36 plus 16, it's the square root of 52. You can take a little bit more time doing this. That's a 2 root 13. Take a 4 out.
Oh, yeah.
2 square root of 13, right? Okay. So 4 times 13, and then it's the square root. 4 is 2, so 2 root 13 remains. If that's the distance, what's the radius? That's diameter. What's the radius?
2 root 13.
That's a
Oh,
whole.
the radius you have to.
So that's 2r. That's 2 radii.
You have to score times 2, right?
So divide by 2. Our radius is what?
4 root 13.
Just a what? No, that's doubling.
Oh,
We're halving it, right? Because we have radius is half of this.
2 times 13, which is 26.
No. So 2 root 13 is diameter. What's just the radius? Half of it. What's half of that?
Oh, just root 13.
Yeah, exactly. Root 13. Now,
Oh,
what's
you
r
got it.
squared? Anybody know what r squared is now?
It's 13.
13. Cool, right? Look at this. This is our, now you're good. That's the equation of our new circle. So this is the equation, the relation that gives you the circle that I've drawn in black that is given by the 2 points making that diameter. And you can check, for example, 2, negative 1. Let's make it easy. What's 2 plus 1?
3.
3 squared is 9. Put a negative 1. What's negative 1 minus 1?
Negative 5.
Negative 1 minus
Oh,
1.
sorry. Negative 2.
And what if you square it?
4.
What's a 9 plus a 4?
9 plus 4 is 13.
There we go. All right. Let's stop the video here. Everybody, hope you understood and enjoyed it. With the 3 examples, I think that will be sufficient to really completely understand how to graph circles and relations of them. Okay?